So xy to kx, ky is the algebraic representation for dilation. The algebraic representation for dilation. xy to kx, ky. Where k, the letter k, stands for scale factor. Or the letter k stands for scale factor. This will tell me by what scale, by how big or how small the figure is getting. So we're going to make some observations real quick so we can, like I always say, I want you to discover learning rather than me telling it to you because you'll understand it better that way. So a dilation is either getting bigger or it's getting smaller. We use the word enlargement to say something gets bigger. And we use the word reduction to say something gets smaller. So for the notes that I gave y'all at the top where it says K equals scale factor. K equals scale factor. K represents the scale factor. So either my K will tell me something gets bigger, which means enlargement, or K will tell me something gets smaller, which means reduction. And we're about to see what K value that does that for. So let's look at this table. And we want to see what happens when we multiply certain numbers. So let's say I started off 56 inches. And my change in height, I want to be 1/8 as tall. So if I wanted to figure out, well, what is 1/8 of 56, I can multiply 56 times 1/8. 56 times 1/8. Sorry, I know I told y'all to lock your iPad, so I'll just go ahead and do it. 56 times 1/8 is 7 inches. Okay. So let's say I was 60 inches, something was 60 inches, and I want to make something that was 2/5 times as tall. 60 times 2/5 is 24. Let's say something was 60 inches, and I want it to be 1.5 times as tall. 60 times 1.5 is 90. Let's say something was 24 inches, and I want it to be 5/3 times as tall. 24 times 5/3 is 40. And let's say I have something that was 30 inches and I want it to be 2 times as tall. 30 times 2 is 60. So I want you to look at these numbers. And right now, just in your head, make some observations. I want you to look at what happened. When I multiplied 56 times 1/8, what happened to my number? When I did 60 times 2/5, what happened to the number? 60 times 1.5, what happened to the number? 24 times 5/3, what happened to the number? 30 times 2, what happened to the number? See if you can make an observation here. There's something very specific that happened based on the number that it was multiplied to. So just think. If you feel like you know, you can go ahead and raise your hand and say what you think it is. I just realized the number was different from the paper. Esther, what do you think?
So basically what I've noticed is that when the change in height was greater than, like, it was greater, like, equal to, like, 1 or more, then, like, the new height would increase. Like, it would, I guess it would be, like, enlarged. And then if it was less, so, like, for example, in the 1/8 and the 56, I got way less, we went to 7.
Mm-hmm.
So, like, it's going to reduce a lot.
Perfect observation. So if you did not hear on Zoom, Esther said When we multiplied a number and it was less than 1, 1/8 is less than 1, 2/5 is less than 1. These numbers, when we multiplied the starting height to the new height, it got smaller. So it went from 56 to 7, 60 to 24. So my height got smaller. But when I multiply by something greater than 1, 60 went to 90, 24 went to 40, 30 went to 60. It got bigger. So that's a perfect observation. So these were enlargement, and these were reduction. So what does that tell us about our K value? That tells us that if my K is between 0 and 1, if my K is between 0 and 1, then my figure will get smaller. So if my K value is between 0 and 1, my figure will get smaller. It will be a reduction. Because anytime you multiply something by less than 1, the number will get smaller. But if my K value is greater than 1, it will get bigger. This is huge. Make sure you write it down. This is just supposed to be a star. So if my K is between 0 and 1, it's a reduction. Or gets smaller if you don't understand the word reduction. If my K is greater than 1, it is an enlargement. It is enlargement. My figure gets bigger. So I'm going to be honest with y'all. Sometimes on like the STAR test and stuff, you can literally not have to do any work. Just looking at the answer choices, you can figure out, well, if my figure is getting smaller, my number should be less than 1. So that has to be the answer or whatever. Okay. A lot of the time it's really process of elimination. So let's look at our first image. Okay. We want to compare the pre-image to the image. So which one's the pre-image, the small triangle or the big triangle? The small one. And I know that because it does not have the prime notation. So the small one is the pre-image. The big one is the image. So did it get bigger or did it get smaller? Bigger. So I know my K has to be greater than 1. That's number 1. I know my K has to be greater than 1. So let's write down our pre-image coordinates first. Where is A? Yes, -2, 0. Where's B? 0, 3. Where's C? 2, 0. All right, now let's get our image coordinates. Where's A prime?
4.
B prime? 0, 6,
Oh, yeah, 0.
And C prime?
4,
4, 0. So we want to figure out how much bigger, by what scale factor, did my triangle increase? Okay, by looking at the numbers, you might figure it out in your head pretty quickly, but the numbers will get harder. You're going to see fractions. So I want us to just take this step by step. To figure out scale factor, to figure out what K equals, we do something called new over old. New over old. If I circled these first 2 letters, what would they spell? No. So this is how I memorized it. How I know it's new over old. It spells no. New over old. The first 2 letters spell no. That's how I memorized what to do. Okay, so new over old. So we need to take a coordinate from our new figure, which our new figure is the image. And we need to take a corresponding coordinate from our pre-image and set them on top of each other. So let's just do A prime over A. So A prime was at -4, 0. So pay attention to this part, because once we get this, the rest is going to be easy. A prime is at -4, 0. A is at -2, 0. And just like I circled the no part, I'm going to circle one of the numbers. I can circle the x's or I can circle the y's, but the y's are 0, so I'm not going to circle them. I'm going to circle my first two x's. What is -4 divided by -2? 2. So that means my k equals 2. That means my triangle got bigger by a factor of 2. Therefore, my algebraic rule is 2x, 2y, because it got 2 times as big. 2x, 2y, because it got 2 times as big, or twice as big.
And then if you were to check with any of the other
Perfect. I love what you just said. If I were to do this with any of the other coordinates, it should be the same number. It shouldn't be different because everything would be multiplying by the same scale factor. So if you go look, if it's 2 times as big, that makes sense. If I go to my pre-image coordinates, -2 times 2 is -4, which gives me my new coordinate. 3 times 2 is 6. 2 times 2 is 4. So I multiplied my image by 2 to get to my, I multiplied my pre-image by 2 to get to my image. So just to prove what Esther said, if I did B prime over B, you don't have to write this down. 0.6 over 0.3, 6 over 3 should also give me 2. So my scale factor is 2, no matter which coordinates I use. Ask me questions. That's literally it for learning. I mean, we're going to do more examples, but yes, ma'am.
Would you multiply the 4 times 4
Right here? Divide. Yeah, divide. So anytime like you see like something on top of another or like a line in between it, like a fraction, it means division. Good question. So it's division. To find scale factor, we divide, but once we have the scale factor, we multiply. Alara?
So for the first one, like that we did,
Mm-hmm.
that one we multiplied it, right?
So like the right here or down
No,
here?
The first slide we did.
Oh, right here? Yes.
We multiplied that one.
Yeah, so we did this just to realize what if my k value was less than 1, it should be reduction. If my k value was greater than 1, it would be enlargement. So this is if we already had k. So like this is saying like, oh, if we have k, we would multiply it to find what our new or what our image would be. This we divided it to find k. So we did division to find our k value.
So if you already have k, it's multiplied, but if it's defined k, it's divided.
Perfect. Perfect explanation. Thank you. So let's look at another one. Okay. Is this the one on the next one on y'all's paper? The circles? Okay. All right. So I don't know why it says A, B, and C. Forget what my thing says. Okay. We're gonna find a coordinate on figure 1 and figure 2. So it says figure 1 is dilated to figure 2. So figure 1 is dilated to make figure 2. So did it get bigger or did it get smaller? Smaller. So because it got smaller, I know that my k value has to be between 0 and 1. So it got smaller, so I know my k value has to be between 0 and 1. So here, I don't have points labeled. There's no points labeled. So I have to pick a point on both of the circles that are the same point at the same location on each one. So for example, figure 1, I could choose this point right here. Let me choose a different color. So I'm going to choose 0.50 on figure 1. So which point corresponds with that point on figure 2? 2, 0. So I'm going to use these 2 points. So figure 1 was dilated to create figure 2. So which one's my pre-image? Figure 1, 50, perfect. So that means figure 2 is my image. So we need to do new over old. So remember, new is your image. So this is the new figure that's created. Your old is the pre-image. So the image coordinate, like Emily told us, is 5, 0. The pre-image coordinate is 2, 0. Oh, oops, sorry. Just kidding. Erase. The image coordinate is 2, 0. My bad. The image coordinate is 2, 0. The pre-image coordinate is 5, 0. Got mixed around there. So when I divide 2 divided by 5, I could get the decimal, or I can just leave it as 2/5. So 2 divided by 5 is 2/5, or if you prefer decimals, 2 divided by 5 is 0.4. So my scale factor equals 0.4. So my algebraic rule would be 0.4x, 0.4y. All right, ask me questions. My Zoomies, any questions? Can I get a virtual thumbs up if we're good? All right. So, and this makes sense. 0.4 is between 0 and 1, so that it got smaller. So this number makes sense. So that's another way to check yourself. So just like we said earlier, it doesn't matter which points you would have done. So for example, if I chose to do these 2 points instead, it would be the same answer. So this is at -5, 0. This is at -2, 0. -2 over -5 is still positive 0.4. Okay, so no matter which point you choose, they have to be corresponding points, meaning they're at the same spot on both circles or both figures, but it should not make a difference. No questions? Good. All right, last one. So this one looks a little funky, so let's look at it. Okay, so we don't need, so again, I'm going to ignore all this. We don't need all the coordinates, A, B, C, and D. We just need to choose one of the coordinates. So which one do you want to do? A, B, C, or D? A. All right, so we're going to take coordinate A and A prime. So will it be A prime over A, or will it be A over A prime? A prime over A. So new over old. So the image over the pre-image. So A prime is at what? 6 and what? 6.
No.
And it's like in the middle. I think it's 1.5.
Yeah.
So 6, 1.5. And where's A at? 4, 1. All right. So here we have, it's the same thing. We can either divide the x's with the other x, or I can divide the y's with y. Since there's no 0 in this one, it doesn't matter which one you do. So 6 divided by 4 or 1.5 divided by 1. Either way, what will it give you? 1.5. So my scale factor equals 1. There we go. Sorry, guys. My internet went out. Okay. Let's see. Is it still recording? Yay, it's still recording. Woohoo. All right. So my algebraic rule is what?
5x.
Perfect. All right. Sorry. Technical difficulties. Okay. Alrighty. Okay, so yes, 1.5x, 1.5y. All right, so here's the things that we need to make sure we understand. Dilation does not preserve congruence. This is the only one out of translation, reflection, rotation, dilation. Dilation is the only one that does not preserve congruence. Unless the scale factor was 1, right? Because if I multiply anything by 1, it would stay the same, right? But if it's getting bigger or if it's getting smaller, it does not preserve congruence. These are the 2 points I need you to know. If my k is between 0 and 1, it gets smaller. If k is greater than 1, it gets bigger. On the bottom of y'all's paper where it says from pre-image to image, the figures are similar but not congruent. That's what you're putting there. Similar but not congruent.
Congruent mean equal?
Yes. Who is this Shania person? I don't know. I'm scared. I'm gonna just let them in. So it does not preserve congruence. So it either gets smaller or it gets bigger, but they're similar. That means their sides are proportional. It does preserve orientation though, because it stays in the same position, facing the same direction. So they posted it on social media, and then like random people would just join it. So dilation is the only transformation where it does not stay congruent. That's what that second line says. Dilation is the only transformation where it does not stay congruent.
So they're not congruent, but they are, you said what else?
They preserve orientation. So it does preserve orientation.
And dilations are just transformation or does not stay?
Where it does not stay congruent. So this is just me drawing something. Okay, so what I want you to notice is kx, ky. This is the only one. This is the last blank on your paper. Dilation is the only transformation where the algebraic expression is multiplying the number. So this is the only one that has a number multiplied to the x and to the y. Okay, did we feel like that made sense? Like we feel like we understood it? Okay. All right.